Module 5, Lesson 6, Graphs of Linear Functions and Rate of Change. So what we're going to look at here is some tables. We're going to try and figure out if these tables represent linear equations or linear functions or not. And yes, of course, we could take these points and we could graph them and see if they fall in a straight line. But there's other ways that we can do that when we are looking at tables. So let me zoom in on this table so you can see. All right, if we compare the change in the x and the change in the y, these amounts need to be proportional. So here we're going up by 2, 1, and 3. Here we go up by 2, 1, and 3. Now, it doesn't have to be the same amount every time, but if we divide 2 by 2, or 1 by 1, or 3 by 3, we will always get the same amount, which means our slope is 1. Our slope is consistently 1. So this will be linear. Okay, looking at the second one, if we look at our changes, this side goes up by 1 every time. This side goes up by 5, and then up by 7, and then up by 9. So it looks like there's a pattern here, but it's not going to be the same. 5 divided by 1 is not the same as 7 divided by 1 or 9 divided by 1. These are not the same thing. So this is not going to be linear, non-linear. And to come up with the equation for this is going to be a little bit more difficult. Back here, if the slope was 1, that means our equation would be y equals, I'll squeeze that down here, 1x plus, and then we could figure out what our y-intercept was. Well, in this case, it's going to be plus 3. Okay, if you take these x numbers and put them in here for x, you're going to have to add 3 to get these y numbers. Like I said, this is nonlinear. If you think back to nonlinear back in Module 4, we said nonlinear means we have x to a power, we have the square root of x, we are dividing by x, some such thing like that. If we actually look at these aren't too difficult to figure out. It's 2 times 2, 3 times 3, 4 times 4, 5 times 5. So our y answer is just our x answer to the second power, or squared. Sometimes we can't figure out the equation because there's not anything obvious, but that one's not too difficult. All right, again, we're going up by 1s on this side, so we just need to be consistent on this side. Going up here by 4, we go up here by 5, and then we go up here by 3. 4 divided by 1, 5 divided by 1, 3 divided by 1. None of those are equal to each other, so this is again going to be nonlinear. And there's not really a pattern here. We would not be able to probably get an equation for this. All right, and if it's nonlinear, there is not a slope. There's not an obvious slope. It's going to be changing. The slope will change from one part of a graph to the next because it's not a straight line. All right, here's the next table we're going to take a look at. So if we see, to check to make sure this is going to be linear, we'll figure out what it's changing by. From 2 to 3.5, it goes up by 1.5. This goes up by 0.5, and then this goes up by 0.5. Over here, we go up by 3, by 1, and then by 1. So 3 divided by 1.5, 1 divided by 0.5, and 1 divided by 0.5. If you simplify those, oops, you will get 2 every time, and therefore this is linear. If it's linear, then we can write the equation y equals mx plus b. We just have to figure out the slope and the y-intercept. Well, believe it or not, you just figured out the slope. You can take any 2 points, set them up and subtract them with the coordinates, and you will get the slope. Well, what we did is just doing that. So we have y equals 2x. Now we have to figure out if we're going to be adding anything. If I add 2 to this, if I multiply this by 2, I need to still add 1 to get these numbers. 3.5 times 2 is 7. We have to add 1 to get to 8. Now we could also try to find the missing numbers here. Every time up here, every time we went up by 1, we went up by 0.5 over here. So if we're going to change over here by 1, 7, 6, 5, 4, 3, 2, then we are going to, oops, I missed a 0.5 here. 2, 1. Okay, so every time we change by 1 here, we change by 0.5 over here. So that means our amount at 0, if you're in the wind class, you know, the amount at 0 is your y-intercept. And then if we just take two of these points, let's do 2, 5 and 3, 7, and subtract them, we get -1 and -2. -2 divided by -1 is +2. So our slope, y equals 2x, plus our y-intercept is the amount at 0, which is 1. Same equation, it's actually the same table of data. We are just putting in the rest of the points and looking at it a little bit closer. Okay, so see if you can find the slope using 2 points. See if there's a pattern to make it linear, and then once you know the slope, either find the value at 0 or just figure out what you have to do, what else you have to do to your equation to make these numbers come out.